Hi everyone, welcome to this series of videos for the topic of vectors. This chapter is important for mathematics and it also forms the basis for the next chapter, that is three-dimensional geometry. There will be a series of videos for this topic. In this first video, I will just like to talk about very basic stuff and I will try to define vectors. I believe that there is a lot of confusion among students about even basic things of definition of vectors like position vector, line vector, unit vector and magnitude. I think if you can really focus on this video and really try to understand the difference between position vector and line vector, that will clarify a lot of things for you. So let me start by defining what a position vector is. So first, before I am going into position vector, let me just briefly summarize vectors for you in case you are not familiar. I believe you have already learned about vectors in chapters of physics like kinematics and forces and all that. You should know that vectors are quantities which have both magnitude as well as direction, and they are very important for in general for scientific development. So let me start by defining what are position vectors. So a position vector is a vector connecting origin to a point. Okay, and as the name suggests, basically this position vector is about a position of one point, and I think this is where a lot of students get confused, even the most basic definition of position vector. So let us say we have so a good thing about vectors is that it will always be in 3 dimensions and that will be really helpful for you in the next chapter of three-dimensional geometry. So that is why it is important for you to understand position vectors and things like line vector, unit vector. So let us just initially focus on position vectors. So what is the definition? A position vector is a vector connecting origin to a point. So let us say we have a point P with coordinates Px, Py and Pz, and position vector is, let us call this as x-axis, y-axis and z-axis. Position vector is a vector connecting origin, which is O, to the point P and pointing in direction of P. This direction pointing is very important, because if it is in the opposite direction, then the vector will be something else. So whenever we write a vector OP vector, this is called OP vector. The first vector is from where the arrow line connects to the second point, and P, the second alphabet, which is P in this case, OP vector, is the signifies the direction of the vector. For instance, what I am trying to say is that if you have OP vector, then the vector will start from O and end at P. Okay, and in this case OP vector actually means Px I cap. I hope you are familiar with I cap. I cap means the direction in the x-axis plus Py j cap plus Pz k cap. Okay, so x-axis, y-axis and z-axis. Okay, another point that you might want to know is that magnitude of OP vector is square root of Px square plus Py square plus Pz square. Okay, so let us just take a very quick example for this. If we have a point A, let us say we have a point A, with coordinates 3, 2, 1, what is position vector? And its magnitude. Okay, and the answer is we can very quickly write the answer. So we will write OA vector is 3i cap plus 2j cap plus k cap, and OA vector magnitude is square root of 3 square plus 2 square plus 1 is square root of 14. Okay. So just to give you a very quick example, that position vector is always and always for a point. Position vector is always for a point. Okay. Please do not forget this very basic definition of position vector. Trust me, it will happen. It will sometime happen during the chapter of vectors that you will get confused if you forget this point. So please try to remember that position vector is always and always for a point. Okay. Now let us try to move to a new type of vector, which is called the line vector. So position vector is for a point and line vector is for a line. So as simple as that. So if you have a line, let us say connecting 2 points A and B. So if I write small a vector here and small b vector here, so what does this mean? A vector is for point A and small b vector is for point B. Whenever you see something like this in brackets, it just means because it is for a point, it refers to the position vector. In other words, A vector is nothing but OA vector and B vector is nothing but OB vector. And what are OA vectors and OB vectors? They are OP vector, like position vectors of point A and B. So even this basic thing, people get really confused. So whenever you see point A and something written in the bracket of that, that always means it is a position vector. Okay. So what does line vector mean? So line vector means connecting 2 points, and if we have something like AB vector again starting from A and ending at B, so direction arrow goes from A to B, then this vector is defined as B vector minus A vector, or in other words, AB vector is OB vector minus OA vector. Okay. So let us try to take one example and quickly hopefully you will be able to understand what I am trying to say. What is the vector joining sin theta I cap plus cos theta j cap and zero comma 0 comma 1. Okay. What is its magnitude? So let us try to find the answer for this very quickly. So we have been given, I mean, it might be a little confusing of how it has been written here. So sin theta I cap plus cos theta j cap is basically a point for which you have been given a position vector. So joining this and this, so we will assume that A vector is sin theta I cap plus cos theta j cap, and theta can be any parameter. Basically theta is an angle and a parameter here. It has not been given to us what is this value of theta, so it is fine, but we can still calculate the answer. And B vector is nothing but k cap, right? So what will be B vector minus A vector? Will be k cap minus sin theta I cap minus cos theta j cap, and magnitude of AB vector would be similar to like we defined OP vector, magnitude basically squaring all the components. So minus sin theta whole square plus minus cos theta whole square plus 1 whole square, and sin square theta plus cos square theta is 1. So AB vector magnitude is root 2. Okay. So in this part I just wanted to emphasize that line vector is for a line and position vector is for a point. Now there are also some vectors which people get always confused about. So here both the vectors are fixed because it always started from A and it went to B, and this started from O and went to P. However, you should realize that sometimes vectors are also freely used, in terms of that the vectors are not fixed. They only fix the magnitude and the direction, but they don't fix the position. For instance, if I have a vector, if I define a vector, let me create another space here and just call that as a free vector. Okay. If I have been given a vector A and I have been told that it is I cap plus j cap plus k cap, and I have not been given any other information about this. So what would this vector represent? This vector represents a lot of things. For instance, it can represent a point such that OA vector, let us say this is the point 1, 1, 1, then OA vector could be I cap plus j cap plus k cap. Similarly, this can also represent a line vector, which means that it can, the B vector minus A vector, for instance, it can join 2 points and the difference can come out as I cap plus j cap plus k cap. Okay. However, free vector, by free vector I means that I just know the direction and magnitude, but it is free to rotate in this 3D space. For instance, let us say there is this vector which I am holding here. If this vector, it can freely rotate, it is not changing its direction, it is not changing its magnitude. So that is a free vector. So if you have not been specified a specific position from where it starts from origin and ends at a position, or it joins 2 points, it can also be a free vector. And I want to emphasize this because you will see later in this chapter that many times it happens that people really get confused about free vectors, that they are not able to understand it. Similarly, they get confused between, oh, what is a vector connecting 2 points, and they get confused whenever they see notation with a vector in the brackets or small v vector in the brackets. So just to summarize, whenever you see a point, it always means a position vector. Whenever you see a point, it always means a position vector. Whenever you see a vector joining 2 points, it means a line vector, which can be calculated like this. And whenever you see something just written like this and not specified whether it is a point or whether it is a line vector, then it means it is a free vector which only has a fixed magnitude and direction and can move freely around the space. Okay. Now, till now I have only talked about the magnitude of the vector here, AB vector, OP vector, that you can just take the x component square, y component square and z component square and take a square root of that. However, there is something also very important for a vector, and that is its direction. So let me start by defining unit vector. So whenever I write a vector A, which is for instance written here, I can also write vector A as magnitude of vector A into unit vector. Okay. So what does this mean? This means that A vector has some magnitude which you can again calculate by squaring x component, y component, z component and adding them and taking a square root, and this A cap is nothing but the unit vector, or something which I really prefer to use, the direction of the vector. So unit vector and direction are synonymous. Many people get confused about this. Unit vector and direction are synonymous. So whenever you have a vector, it is a multiplication of its magnitude into its direction or its unit vector. So for instance, if I have to calculate a unit vector, calculate unit vector of A vector, vector A. If you want to do that, then you can write A cap as vector A by mod of A. Vector A in this case is I cap plus j cap plus k cap, and mod of A is square root of 1 square plus 1 square plus 1 square, and this means I cap plus j cap by square root of 3. Okay. In other words, I can also write that A vector is root 3 times I cap plus j cap plus k cap by square root of 3. and this is the direction, which is the unit vector, and this is the magnitude. Okay. So if you want to calculate the, let us just write another question. What is the direction of x-axis? X-axis. So if you have a direction of x-axis, direction means a unit vector. So in that case, a cap would be, direction is something with a magnitude of 1, and we know the direction of x-axis is I cap, and it also has a magnitude of 1. So it is just I cap. I cap is nothing but a direction. So whenever I write something like px I cap plus py j cap plus pz k cap, it means that I have moved px in the x direction, right, I cap, and then I have added something with, and I have moved py in the z direction, and then I have moved pk in the pz in the k direction. So that is how you define direction by unit vectors. So till now in this video we just covered very basic stuff. Position vector refers to a point, line vectors refers to joining two points, free vector refers to a vector which is neither a point nor a line, just something that can move freely around the space, has a fixed magnitude and a fixed direction. And at last, unit vector means just the direction where you divide the vector by its magnitude, and we did a very quick calculation to see that. So I hope this was clear. Just take some time and digest these things, and in the next video we will talk about things like addition of vectors and section formula. Thank you.